Hi everybody. In my third try to get this right. I think I can make it happen this time. Uh, we're going to find the equation of a line tangent to a circle. And we begin with the equation of this circle. We're going to want to graph it, but it's not ready to be graphed. I don't know its center, I don't know its radius, I don't know anything about it much. Just because it has a sum of squares, x and y, I know it's the equation of a circle. Let's lay out x's with x's and y's with y's and leave the constant on the right hand side. So this would begin with x squared minus 4x plus, going to leave a blank right there so I can complete the square. You should too. Y squared plus 16y plus, leave a blank there, equals, and the constant on the right hand side, there's 32. Now, we would like for this to become a perfect square binomial, and this one as well. To make that happen, we have to add the perfect number here and there. To find that number, you take 1/2 the coefficient of the linear term. Half of that would be -2, and you square it. You get a +4 there. When you add 4 to one side of an equation, it would be clever to add 4 to the other side as well. Same idea here with y. Take 1/2 the coefficient of the linear term. That would be 8, and square it. And we got 64. Since you added 64 to this side of this equation, let's add 64 to the other side. Now that we've done that, we have completed the square, and this entity is a perfect square binomial. So is this one in y. Another perfect square binomial. You figure those out, and I'll add these up over here. 32 and 4, there's 36 and 64. I get 100 right there. Now, what goes here? This is important. You got to do it before I tell you. The square root of x squared falls here. The square root of the constant falls here. If this is negative, so is that. I invite you to multiply x minus 2 times x minus 2 and see if you don't get this back again. You should. Same idea here. Take the square root of the y squared, it's just y. The square root of 64 will be 8. If this was negative, so is that. If this is positive, so is this. Now, that's the equation of a circle. This was already the equation of a circle, but this is one we recognize. We know the center and the radius of this circle. Absolutely we should. The center, and it tells me this is point Z, so the center is at Z, and it's at, you could tell me, 2, -8. And the radius is 10. Here we have the square of the radius. I'm going to show the graph of that circle. It has its center at 2 over 2 and down 8, right about there. It has a radius of 10. I got a compass. I think that's graduated to 10 right there, as best I can make this. I'll try to show that circle quickly and easily. I'll do it the quickest way I could. I'll spin the paper. Try to get that circle in place. Sometimes you got to do what you got to do. There, I think I have a pretty good graph of this circle. As for the circumference of the circle, not what I was thinking, but the circumference of a circle I know is given by 2 times pi times a radius. So the circumference of this circle would be 2 times pi times 10. 20 pi. And the area of a circle is given by pi times the radius squared. So the area of this circle, 100 pi. We should be clear that this is linear units, a unit of length, and this is a unit of area. 100 pi square units would fit there. Let's move to this next part. This gives me a chance to practice this idea twice, but we're going to do it once with point P first, and then again in a minute with point Q. Point P shows at 10, -2, and I'll go to the right 10 and down 2, and that's just about right there, There's our point P. And where we're going with this is we're going to find the equation of a line that is tangent to the circle at point P. To do that, we're going to need to know the radius of this circle. Not the length of the radius, we already know that is 10, but we're going to have to know the slope of that radius. It has to be for the slope of the radius ZP with point Z. The center of the circle was at 2, negative 8. And point P, we're told, assigned to be at 10, negative 2. It has to be for this slope, and you ought to be thinking about that slope ahead of time. Would it be positive? Will it be negative? What do you expect? Then let's instantiate. So, going to that slope formula here, y-coordinate negative 8 minus y-coordinate negative 2 over x-coordinate 2 minus x-coordinate 10. Be a little bit careful. That's a negative 8 and a positive 2. That'll give me negative 6. And 2 take away 10 is a negative 8. Reduce that fraction, a negative divided by negative, that's a positive 3/4. Is that a reasonable slope for this? Up 3 and over 4? I think so. Give the slope of a line that's tangent to the circle at point P. We're going toward the equation of this line right there, aren't we? And what you should be thinking is, that's got to be perpendicular. So the slope of a line that's perpendicular to this would be negative 4/3. I'm going to say slope of a perpendicular, negative 4/3. That's a big deal. That should be the slope of this tangent line. Give the equation of the line tangent to circle Z at point P. Bearing in mind point P was at 10, negative 2. And we're going to have to be perpendicular, so we've got to have the slope of the perpendicular to be negative 4/3. Whenever I write the equation of a line, I'm going to work from y minus y sub 1 equals m times x minus x sub 1. And let's burn this down. Y minus negative 2 is really going to be y plus 2, isn't it? And for the slope, negative 4/3 is what that should say, times x minus the x-coordinate 10. Let's multiply through those parentheses. Don't be lazy. Keep the left-hand side. Y plus 2 equals, multiplying through the parentheses, negative 4/3 x. And here I have a negative times a negative, therefore a positive. And 4/3 times 10 will be 40/3, which is 13 1/3. You think that through as you need to. But when we multiply those, we get 13 1/3. As we want to isolate the y guy on the left-hand side so we can graph this with a calculator, got to subtract 2 from both sides, and I come up with y equals negative 4/3 x. When I subtracted 2 from both sides, plus 11 1/3. I think that's the equation of that tangent line. But that would mean that y-intercept's got to be 11 1/3. And that doesn't look so bad. That's probably okay with me. I'm going to accept that to be truthful. Now this is just for practice. We're going to do that same idea again. There's this other point on that circle at negative 4, 0. Left 4 and up 9 right about there, huh? That's point Q. Worked pretty well. And we're going to find that. We're working toward finding the equation of the line that's through point Q that is tangent to our circle Z. We'll need the slope of this line, so we got to figure out about this radius to that point of tangency. Point Q being at negative 4, 0, and the center of the circle being at Z at negative 2, excuse me, at 2, negative 8. We'll need the slope between those 2 points. You should be thinking ahead of time. Will you expect a positive slope or negative? 0 minus negative 8. Y-coordinate minus y-coordinate over, if I use that y guy first, negative 4 minus 2, which yields a positive 8 over a negative 6. So I'm looking at a negative 4/3. Is that a reasonable slope here? Could that be down 4 over 3? I'm thinking so. What about the slope of a line that's perpendicular to that? Be a positive 3/4, huh? Yeah, I think we got a lot of perpendicularity going on here. I think all these lines form a nice little rectangle at least, if not a square. Well, actually, since these are congruent and opposite sides of a rectangle are congruent, it must be a square, huh? I'm not going to fret any more about that. I'm going to go back to finding the equation of this line. I want to go through point Q, which is at negative 4, 0, and I want to be perpendicular with a slope of 3/4. And I'm going to use that formula, but I'm not going to write it down because I already remember it. Y minus 0 equals 3/4 times x minus negative 4. That'll be x plus 4, won't it? Let's multiply through those parentheses. That y minus 0 is just going to be y, but I got 3/4 of x plus, what about 3/4 of 4? That's just going to be 3, isn't it? Alright, so I'm thinking that's the equation of that other line, and it should have a y-intercept of 3 and a slope of 3/4. And y-intercept of 3 looking pretty good, and a slope of 3/4. I'm going to take it. I think it looks pretty good. Yeah. I think it's a really nice exercise. For me to put this on my calculator, I got to solve it for y. It would be dark to solve this for y. You'd have to put it in this form first. Let's take a second and make that happen. I'm going to solve this for y and put it on my calculator. X plus 2 quantity squared plus y plus 8 quantity squared equals 100. Because I'd like to graph this on my calculator only graphs functions, I'll have to solve this and say y equals. And I'm probably going to get a couple of things, one for the upper half of that circle and one for the lower. You'll see about that right away. Solve this for y. I'm going to bring that x plus 2 to the other side, the x plus 2 quantity squared, and leave this y plus 8 quantity squared equals 100 minus x plus 2 quantity squared. I think it's kind of easiest if we don't square those out. Just leave them in this form. We still want to get y alone, and the only way I can get y alone is to take the square root of both sides of that equation. So that's what I got to do. And the square root of this thing squared is just going to be that y plus 8. Equals plus or minus the square root of 100 minus quantity x plus 2 squared. To solve that for y, you got to bring that 8 to the other side. It's going to be y equals negative 8 plus or minus the square root of 100 minus x plus 2 quantity squared. I'm going to put this on my calculator. Once with a positive and once with a negative. Negative 8 plus the square root of this and negative 8 minus the square root of that. And then we'll get a look at that graph. And the graph ought to look a lot like this. Let's see how that goes. I've got the equation of the circle for y sub 1 and y sub 2. I also have the equation of those two tangent lines. I want you to see how this looks. I'm going to alter my window just a little tiny bit. I'm going to say from negative 21. Just so you can watch it appear. Watch this graph. There's that circle. Now how about those tangent lines? Oh, I turned them off. Let me get those tangent lines to show. If I hit enter there and move up here and hit enter again, then I think those tangent lines will show. There's one of them. Looks pretty good to me, and there comes the other one. I'm saying that looks a lot like this, doesn't it? Yeah, I'm going to take that to be accurately done. This circle does, the calculator doesn't graph circles very well when these places are nearly vertical here and there. It denies them. It says it's not a function. A vertical line's not a function, and that's so close to vertical, the calculator says it won't deal with it. But I think it works pretty great, and I hope that you